Good morning, everyone, and welcome back to the last and final day of our Stardust Festival. It's been this fun filled week with a lot of really inspiring speakers, some really fun activities with the children, as well as some great launches from the universities here for our Launch Canada rocketry competition. Ani Boju Madison, Indigenous Cause. I would like to acknowledge that the lands we are standing on, Treaty 7, Anishinaabe Cree territories. With that, I'd like to thank you and introduce you to our first speaker for today, Miigwech. So this morning we have Elif Keefe joining us today. She is an architect and designer at Keefe Design Studio, and she supports many companies on many diverse projects. She's also a master's student studying sustainable buildings and space architecture. She's also founded OSA, the Outer Space Architects. She says that she has a natural passion to be one of the architects who lay the foundations of space migration for improving projects in space architecture and specializing in sustainability in orbit and on the moon, Mars, and beyond. We're really eager to hear your story, considering that's your passion today. Elif, if you want, you can share your screen and I'll get it up for everybody.
Thank you so much for this nice introduction. And I'm going to share my screen. Yeah, okay. So today I will share about first my story and then where I reach and what kind of projects I did and I do. Starting from the beginning, I found very old pictures that I drew by myself. I was very talented by drawing when I was a kid, and I found these pictures to share to you to tell you about my story from kid childhood until now. And actually, after my secondary school, uh, I couldn't continue education at school. I grew up in a place that actually the women uh, they didn't allow it to continue education in high school and have a dream or have a work. I grew up in a culture that they were thinking that women is occupying the job of the man. That's why they shouldn't go to school. But after secondary school, I I challenged every year and tried to continue education from high school to regular school and uh, and do something as keeping education at the university and the rest. However, every year I ask my parents for permission to continue my education. However, every year I was blocked to continue it. So in the second year, still I ask, please, father and mother, please, brothers. I grew up in among six brothers as a lonely girl, and all of them were, and even culture and people around me, they didn't know actually about that's a normal thing the girl go to school. And the third year, I still ask permission. And after third year, I grow up, my age getting more, 3 years more older than the regular students. And then I said, okay, I will not ask for the permission next time. So I went to high school by registering by myself and continue my education. And every step of me in education were very big challenge for me, and but still I can say that these challenges made me stronger, and these challenges made me to keep dreaming and challenging on the thing that I dream for, I challenge for. And whoever listening to me, the women especially, please just keep challenging and don't afraid of whatever do you hear from people your surround, even that can be your family, your brother even. uh, if you know that you're doing right, just keep going on that. And when I found my picture, the pictures I drew when I was and in that age, It was like 3 years like a prisoner at home, but I improved a lot of skills of me. I was drawing very well, and I wrote uh, stories, a lot of stories, and I finished one of the novel I write, and with this energy, I started high school. I finished my school with as a first student, and and continued my education in a nice school in Turkey, in architecture department. And in the architecture department, I was like unstoppable. I applied all the exchange programs. I moved all around, and it was not still that simple for me. At every step, I was challenging with my family for permissions and stuff, and I found my way anyway. I found my way. Maybe people will wonder about it. Maybe I can leave it for the Q&A part. If they wonder, I can answer, of course, how I challenged and how I found a way with making my family happy and making myself happy as well. And I sailed my ships to the sea and continued a new journey. And in the time of university, I did a lot of volunteering project, and I started doing my hobby, which I really like, is traveling. I did hitchhiking and camping all around the world. Actually, I which I started actually from Turkey, and then from the neighbor countries to the Europe until Korea and China and America. Over 30 countries I traveled, and get gather a lot of experiences about differences, cultures, and languages that helped me a lot for improving my language skill. And I became the five language speaker after that. And these are the projects I joined. It was This was Youth Bus project, and we were like 100 youth. We traveled 15 countries of Europe, and they did some project there. And also did a lot of different activities in volunteering. We was a group of social volunteers in Turkey, and we were always running all around the Turkey for all the emergency situation. When the earthquake happened, when we were visiting the old people and the women shelters, and the orphan shelters, to share happiness and share hope and share our experiences, to give them hope, to love, make them laugh. And with this group of volunteers, we created a science team, and the science team named Stardust Squad. We start in Turkey, and we learn a lot of things in science, and then we share with other people. And a lot of kid, as you see in the above picture, growing up with us and learning a lot of things in science and improving projects. And after that, with this group, from first and second and then the third one, I created by myself. It named Outer Space Architects. We are just focusing on the space architecture. Recently, I volunteered very nice activities in USA. I got a opportunity to visit USA, and in Washington D.C. I joined firstly Human to Mars Summit as a volunteer, and after that, National Space Societies. It helped me a lot to meet astronauts and a lot of space architects. And finally, I met my mentors who always mentored me, helped me, and gave me all the help on the road I walk. And first time I met them face to face in through this program. And I got opportunity to visit NASA by joining the third program Moon to Mars Festival, and I could able to visit International Center of Space Architecture in University of Houston, and finally I met Professor Jeff Hoffman in MIT school and at architecture department as well. I met Professor Nicholas Monkos, the writer of Space Suite Fashioning Apollo, and it was very nice to exchange all the ideas. They supported me and gave me a lot of ideas how I can continue in the space architecture after my master degree in Sapienza University in Rome. And I wanted to I want to continue my master PhD program in USA. That was the reason I visited USA and shared my purpose with a lot of professors to try to find my way for that. And recently, I finished my first class master degree in Sapienza University, and I developed one of the thesis research in outer sustainable buildings engineering, sustainable building in outer space and extreme environments. In the research focus of my research, I considered about climate change, which is a reality, and we are facing on that. And it's fact that we will face it hardly in the future, and we are as the architects we have to be ready for that, and we have to be ready for the time where we cannot find enough resources, we cannot find enough opportunity to live in a nice place. But if we will be ready, we can settle better living areas in the harsh, extreme environment in on any point of the earth. So when you get the source knowledge from outer space, which is the hardest harsh and the hardest environment, it will be easier for us to apply to the earth. That's why I jump into the outer space. And uh, and I wanted to show you what kind of projects I did. Firstly, I will talk about a few Earth architects design I did. They are constructed as well. These are my first uh, one of the lovely design of me on the Earth. Uh, it is just a villa project, um, and maybe you can just see here some Seljuk motifs, which actually the owner required that from me. and and also I design some modern villa projects as well, and these are all constructed. I named this one up down house because actually when you check here, it's kind of the roof is underground but the bottom is the up. And some office project and hostel project and the hotel projects I have done before. But maybe you wonder about how I came into space architecture and what I did. This is our main focus. I worked in aviation over a year, around 2 years. I was preparing for Turkish Airlines pilot exams, and I learned a lot about principles of flying and mechanical, technical things to develop myself in the aviation. And I was a virtual pilot flying Airbus 320, and also was flying small flights and at the virtual and some simulations. And after that, I really wanted to combine my main department, my main major, which is architecture and design, to my passion, which is aviation and space. And I met space architecture after that. When I researched on the Google, I found a lot of space architects are actually available, and I found them And as you see on the previous pictures, I met them in USA finally after a long chat and talk and emailing. And because of this my focus, because of this my energy on the space and outer life, I and my all the reading and research on that, uh, my dreams, which when I sleep I see, we're always focusing on something very awkward. When I wake up, I draw it. Every sleeping time, I design a new spacecraft, and I every time I remember that, and the next day I put a new part on it, and I wake up, I draw again. These weird shapes actually all coming from my dreams when I sleep, and uh, and I wanted to make them real on the earth, on the reality. So I will talk about two projects which I initially supported. Um, First of all, I want to talk about Think Orbitals. Maybe you have heard about them. They are designing or put two space hotel, and I was space architect and supporting space design team for this project. And the Orb 2 is right here over the Earth, and it will serve to tourism, space tourism, and people will be visiting for 1 week, travel 1 week, 2 week space uh, holiday. And as you know that it's a spherical, and but how this spherical shape is combining to each other is made of pentagons and hexagons. Hexagons and initially hexagons are combined with some clips, and then in the inner part the pentagons are combining the rest. And here a whole of it call it habitational module. And here is pentagons, which doesn't have any window, but hexagons have the windows. These are the radiators, and you can see the service model here, and docking port, and with the solar panels. And the second project is Revolution. We built Revolution at the ISU, International Space University, at the Space Architecture course. I've been supported by this International Space University as well for developing in the space architecture. It was the program was with the partnership with the School of Disruption. It is Swiss Institute for Disruptive Innovation. We were developing interplanetary human transportation for 6 crew member for the 6-7 month travel to the Mars. And we made some decisions. We decided to use two starships, and initially, and with two starships to make artificial gravity, which is actually not possible yet, but maybe be possible in the future, and maybe our solution can be as answer for that as well. I will share on that. And initially, two of the starships are launched, but they are doing maneuver in the space and coming nose to nose. And one of it is habitational module, but the other one is cargo. So the cargo one is carrying the part which will make them combine to each other. It's carrying tethers and truss system, and all the solar panels and radiators, and central node. And when it is firstly combined, and then they are extended, but with the extension which for artificial gravity is required. However, we decided to make artificial gravity with the gravity of the Mars, which is 1/3 of the Earth. That's why it helped a lot for our project to have less material to use for the middle part, and also to give opportunity to the crew members to experience martial gravity. And as it is shorter, they can easier making EVA to first habitation module to the center module, or the rest. And when they after that coming back to the coming to the surface of the Mars, it will again, one of them will return around Mars, but the other one will be uh, touchdown. We have a lot of questions after we decide we can make artificial gravity. As you know, that artificial gravity is a really hard question, but why? Because there is Coriolis effect. Coriolis effect has different difficulties. One of it is vertical Coriolisity. When you walked through the direction of the rotation, you feel heavier. When you walked or run opposite of the rotation, you can feel lighter. And when you throw something in the habitational module, it's not directly horizontally coming down. It's just turning. It's radial Coriolis, and after that, you always feel a part of the uh, habitational module heavier because of the rotation. And the lastly, as you know that we have vestibular inertia in our ears, which helping us to feel balance, to make balance, to walk in balance, to run and to move in balance. However, when it's returning, having a rotation for gravity, artificial gravity, whenever you turn your head to right to left, your vestibular inertia is vibrating and it's giving you head dizzy. And this is the hardest thing uh, in the outer space. We have to solve these questions to make more comfortable living area all the 6-7 months traveling. And we answer those questions with some interior design. So whenever you're inside, you have to know which direction you are. So we specified some rooms according to that, and we decided some colors to answer to that. At this point, okay, I think I have 10 minutes. I will try to finish earlier. Um, at this point, also we have another question. When you have this node in the top, which is connected, this part has less gravity because it's closer to the central point, but this part is the farther, that's why it has more gravity. So when if you have decided to make the Marshall gravity, perhaps this part will be Marshall, but then when you go upper, it will be less. Or if you so we decided to divide this part according to the usage of the area. So actively, we use this area, so we have to place the rooms we often use actually. So we divide it into active zones, which is here, and semi-active and passive areas. Passive areas is the top part. We place it here because it's less gravity, so it's better for us to use the bottom part more than that. So the level 0 is just a docking area, and EVA suites are located here, and everything starts from the level 1, and we are placed research and medical area here, and we will be always researching, learning, and developing. That's where actively we are using this part. And the second part, common area, which is helping, which is serving ground under level 1 and level 3 as well. We have a common resting area. It's combined with the uh, pardon, with the level 3. It's included gym and home space. In this part, home, which we named home, is very special area with super spiritual area. It's only designed for the human psychology, because human will forget, will miss many things, will miss their family, and will miss the earth, breath, smell of the grass, and the sound of the bird. These are all the natural things are will be simulated in the spherical area, and it will be really natural. The ground will be real grasses you can just lie on, and have the sound of the wave of the sea, sound of the leaves of the tree, and the sound of the bird and animals, and you can connect family and talk to family, and it's the point to make human feel earth, they remember earth. And this in this area also they have very vast big opening, and the upper levels sleeping quarters divided to according to the number of the crew members, which are six, and here is also the sleeping quarters, second floor. And lastly is the cockpit for first launch. Uh, Six chairs for every of them. And these are our resources. We have done this all the design. Thank you for listening. And this is my presentation. I can stop share.
Yes.
Yeah. Thank you so much.
Great. Well, thank you. That was very interesting. I'm sure that's a really novel concept for a lot of people, like architecture in space. So, I wanted to ask you a question because you have to think in such different ways and work with a lot of different constraints when you're dealing with architecture in space. But is there anything that you learn about space architecture that can help for architecture here on Earth, especially in like northern or remote communities like we're at today at the festival?
Yes, yes, definitely. Uh, actually, as you know, that firstly I show you the Earth projects and then the space project. I was a regular architect designing for the Earth. I was not really focusing on the human psychology, but maybe we have to do that. But we really don't care that much. But when you jump into the space architecture, you have to really have to consider every inch, every point. You have to think is really fine for human psychology, because we are challenging for human factor. And as you know that, okay, we can go to the moon very easily in 4 days and come back. In any urgency we can come back, but if we're intending to go to Mars, it's over 2 years. Like 2 years you have to stay there, and staying in a capsule 6 7 months with all the curious effect and everything. um, you have to think seriously, think on that.
Yes. Um, I think we may have lost you, but absolutely everything you said, that was it's so important, and we can think, and when we start thinking about how we do things in space, it can actually help us be really creative about things we maybe hadn't thought about on Earth. All right, I think Elif is having some technical difficulties, but we are coming to the end. So I would really like to thank Elif for bringing this new perspective. This was the first architecture talk this weekend. It was really interesting and exciting, and um, yeah, I'm really starting to think myself about new ways that we can consider architecture in space and on Earth. All right, everyone. So we will be back in about 15 minutes with our next speaker, Leszek, who is from the Lunara station in Poland.
Hi. So welcome back to the Stardust presentations. Our next speaker is Leszek Oszowski, kind of. All right, nice.
Almost well.
The architect and creator of Lunaris Research Station. It's an analog habitat designed to study human health and psychology during simulated crew planetary missions. I'll just ask you to share your screen again. It disappeared for a few
Sure.
seconds.
I
All
simply
right.
wanted to see you for those few seconds at the very beginning, and now I can share my screen because now we will have a presentation. Yeah, let's share a window. This one. Because is there anything we should talk about at the beginning, or yeah, can I start with the presentation? Uh,
2 seconds.
all
I
right.
seem to have lost my own sound, but people. Okay, here. Try talking.
Yep. Can you hear me?
Yes, I can hear you now. All right,
Wonderful.
so I can
Wonderful.
see your presentation, and
Well, okay.
it's going to be up with you.
Oh yeah. Let me reset that. I forgot that I had to. I was supposed to open up a PDF instead of presentation. Don't worry. We have plenty of time. But I first need to find it. Yeah. hmm But today's talk, once I open, once it's ready, will be about my journey as a space architect. But let me find it. Yes, right. And I will share my screen once again. Don't worry. In 1 second. Okay, now we can start. Because it's all about becoming a space architect. We just heard a testimony from a previous speaker about space architecture. But I will only start at this space architecture part, and we will end at analog habitats, and especially on Lunar's research station that we see here. And it's all about getting there. So it's a story that once you start your journey, things that you first uh, understood as failures, in fact, are something very, very different. So, at the very beginning, and many, many years ago, 9 years ago, I decided to change my regular architecture profession for space architecture, and I found the spaces more design team and together with some friends from my former university, and that forced me to work with different kind of professionals than I usually worked with when I worked on regular architecture. We decided to participate in a competition to design a manned Mars flyby mission. So it was not only about the living space where astronauts were supposed to survive like 2 or more years, but also everything regarding space and mission architecture. So trajectories, your launch systems, your life support systems. And so there was a lot of us working on that, in fact, and we were envisioning how the spaceship should look like. And eventually, we got to the finals of that competition. It was organized by the Mars Society, so we had to go to US, or before that, I had to do some TED talks explaining it as a preparation for the for the finals. Then we went to US, met Robert Zubrin, the founder of the Mars Society, And then we failed. We didn't won because it was our first competition, and I was quite devastated first. But it already showed me that this is what I would like to do for the rest of my life. And a year after, we were approached by a Polish Ministry of, I guess it was some ministry responsible for doing a Expo 2015 exhibition in in the Polish pavilion. So it was. So it was a very nice recognition to show yet another project that was basically an inflatable dome that would allow people to create like this small community on Mars. It was still not the best engineering or design work that we did, but still it was some kind of recognition and it felt good basically. Then we participated in NASA 3D Printed Habitat Challenge the same year. It was all about creating architecture using additive manufacturing, but we unfortunately lost again because it was a competition that European Space Agency was participating in, and other wonderful professional teams, and we were just like graduates back then. So it was once again failure in my mind, although it definitely gave us some new experience and some new set of skills. Uh, I guess the same year, friends from my team participated in international group that won ESA Moon Challenge. So it was a mission architecture study or competition that focused how to go back to the moon in a few years using only existing technologies. And they designed something that resembles a gateway space station that is currently being designed or produced for the future moon missions. Although it was simply a testimony that they did a very good research, what could be very useful for this extended lunar architecture needs. But that was very good. And then someone approached us, our friends, to create our first attempt on analog habitats. So a space where you are doing real life simulations of manned missions, and you can study group dynamics or different aspects in those scenarios. So we tried to build something in the wilderness somewhere in Poland. It was called Mars, but it failed due to like internal turmoil. It was the very first project that we were building and collaborating on in like a very large group of people and collaborators, and it simply fell apart at some point. But we we thankfully um, were able to take those pieces and create yet another attempt that was successful, and I will focus on that in a minute or two. Year later, we once again tried to do our best to design a Mars flyby mission. Failed. Then we failed at designing a small base on Phobos, one of the Martian moons. Although it was also a failure from, um, maybe not a failure, but it was also some strange situation with the organizers that after 2 years they said that in fact we've won, but we were never contacted. So that was, but still in my mind for a very long time, it was a failure. And this is a very scientific graph of my experience with failure and success over time, and you can see that it is a roller coaster of emotions. But every single failure of something that I was interpreting as a failure was always a bit higher when it comes to our proficiency in tackling those topics. And if you focus on, like, if you see a graph that shows how improvement of the certain skill looks and like you can see that the blue line is actual technical skill that you acquire during practicing. So there are always those times when you are getting better, then you stay at a certain level, but your perceived technical skill, something that you feel internally, really is this kind of curve that makes you feel sometimes less worthy, or your skills are you perceive that your skills are worse than are actually are. But it only happens once you have more experience and you really have ability to see what is lacking, or you get this feedback that, for example, you failed this competition, so you need to look at your work and see what was missing there. So then you feel a bit worse about yourself, but it is also a very important step in getting better. And this is exactly what is happening to us, the whole crew. And this is basically what everyone will experience once they decide of decide to acquire a new skill and practice and become better and better. So there will be frustrations, and you can see exactly where and why the frustration happens. So eventually, uh, we uh, we also started doing science, not only those theoretical competitions or reports about space travel. We wanted to do science yeah, using simulations. So first we tried to create our first analog habitat. Then we took those pieces and created Lunaris Research Station. So Luna, Ares, so it's Moon and Mars. And this is where we are simulating mm, those scenarios for researchers, basically, with 6 analog astronauts that being isolated on the former military airfield in Poland. But there were more success. Well, we had more projects that we wanted to show when it comes to future living on Mars. So in 2019, we got second place at Mars Colony competition by Mars Society when we proposed a colony for 1,000 people. We investigated how living and working and sustaining a Mars colony would look like. Eventually, it ended up in the book that is on the shelf of Elon Musk. So that's a nice recognition. I don't know if he read it, but it's always nice to know that we are on someone's shelf. Um, we won several competitions. As you can see, not only our visual fidelity went better, but also we basically started winning a lot of competition when it comes to this speculative approach to space architecture, how our life could look like. But we obviously wanted to focus on the scientific aspect inside Lunaris Research Station, so I can now focus on that. And our habitats, well, normally analog habitats can be located in different places. It depends really on your research angle or research scope. Research scope, Lunaris Research Station is an isolation facility, so it's not located in some extreme environment in a desert or on a volcano or underwater on the Arctic. It's located on the former military airport where we created this isolated environment where we can simulate any time of the day. There's no access to natural sunlight or any way of contacting from the outside with the outside world. And this is where we can do science basically. So we are using one of old hangars as our moon or Mars yard, and then I will show you how we created habitat next to it. But it's important to mention what analog mission simulations are. According to Mars Design Reference Architecture 5.0, analog mission simulation is an activity designed to represent specific scientific, technical, and operational aspects of future space missions using actual or functionally representative systems and operations or procedures under analogous environmental conditions for the purpose of understanding performance and interactions among those systems and operations or procedures, as well as their ability to achieve mission objectives. So basically, those simulations allow for testing a lot of things and how they interact with each other. And it could be a part of technological, it could be medical, it could be sociological, different parts. Sometimes people are testing the habitats themselves. So sometimes you can see that analog habitat is a prototype of some sorts. Our analog habitat is a very simple structure that was created to simulate and allow to isolate people. So it's not any kind, like it's not a prototype of a moon base. It is a space designed to emulate certain features and certain functions, and this space allows for gathering a lot of data. So here you can see that this is our this old hangar. Previously, like bombers were stored there, and we created EVA area, so extravehicular activity area. This is where simulated spacewalks are conducted. We have like 400 tons of basaltic rock, 400 tons of sand there, and this is where we have our moon or Mars. During this period of isolation, and where you live and work, it's a research station, so it is a shipping container structure, and has every single function that you need for to conducting the study. So this is the hangar during one of the simulated spacewalks. uh, Also, you can people are doing their different investigations. Sometimes when it comes to constructors, sometimes when it comes to human robotic collaboration. But most of the mission really they're spending inside the habitat. So there are 7 modules. Every single one is has different functions. So they can work in a workshop, they can go to the gym, they have their whole small office, a dormitory that is basically a small capsule hotel for 6 people, kitchen, biolab where they are cultivating plants, and a hygiene module that allows us to investigate and study a usage of gray water and different strategies of water saving. Basically, this whole structure and the setup is off grid, so they have all the water they need for the mission with them. Mm, and yeah, and so far we did 24, 25 missions already, and people spending their time there are coming from all different corners of the world. Sometimes there are researchers, sometimes there are students that want to gain new experience. But what is most important is that they are contributing for this research, that we are basically trying to gather as much information as possible, not only from their environment. Here you can see that every single module is monitored. We know exactly what the conditions inside of the module are, how much power they're using, how much water they still have, or how much gray water they're producing. So this is this environmental data that from inside the habitat. We see what is happening there on CCTV cameras, but it's also very important that we are gathering data from those participants. And if you can create the same conditions every single mission, so so the conditions inside the habitat are not dependent on time of the year or other external factors. The only changing thing is your crew, and then you can do multiple group studies, and eventually, after, for example, 10 missions, you have statistics for your group dynamic crew. For example, as you can see, our groups are quite diverse when it comes to age, when it comes to gender, when it comes to ethnicity, and this is exactly what we are aiming for. At the very beginning, from 2017, we did several missions, and starting in 2021, we are now doing around 8 to 10 missions a year. So that's a quite a lot of data that we need to process together with our partners and our crew members. And it's and people that are coming here. Okay, 42% are Polish because we're in Poland. There is like 50% of people are coming from the US, and then there is also almost I guess 30 or something percent is Europe, and then there are people from other countries. We are very we are trying to keep our male female ratio in our teams, something that we really think it's quite important. When the teams are well balanced, so we see that people are working together like most efficiently. If there is any disturbance in this ratio, there could be some hiccups and problems, and it doesn't matter in which direction the majority of the crew representatives will go. There will be some hiccups from time to time, but yeah, there's also quite a lot of young people that are coming here because you can imagine that some analog habitats, like wonderful ones like MDRS or high seas, they're located in extreme environments. So this is already something that is a challenge within itself, because you need to be prepared for being in some remote area. And it already adds to the risk. Here, it's a controlled environment. It's an isolation facility, and that it is in the middle of the urban area. So you are definitely safe, and and the challenge is to stay on this small space with others. So basically, you are your own challenge, your internal struggle, and of spending this time with others, and there are no external factors that could be well, dangerous. So that's why we have quite a lot of young people, because they think this is a good first experience with analogs. Also, there's a lot of people like they are always with someone that's more experienced, and this is an awesome opportunity to share more some experience together. And we had some very interesting missions already. Like in 2017, we had experiment with analog astronaut with a disability. Marcin here, he's an engineer, and some years ago, he suffered an accident where he lost both of his eyes, his right hand, and most fingers in his left hand. So it's a major disability that he acquired working as an engineer, but still very capable crew member and engineer when we did this simulation of what would happen to the mission, to the crew, if someone was rendered um, or someone was injured during the mission. It was quite well received because it was featured 2 times during Extreme Medicine Expo in Edinburgh. Then there was a very nice paper in Science about this experience created by the crew and the medical team, and eventually uh, some uh, s- um, some papers from that study were also listed in ESA Para Astronaut project, so that ESA is now selecting a first Para astronaut that will and hopefully go to space in the near future. But the other interesting missions that we did, for example, are with people that always wanted to go to space. So in 2018, we had Sian Proctor on board, and just last year she was orbiting Earth on Crew Dragon. So this is definitely something that we are not expecting, that people that want to become astronauts will be coming here. We are always focusing on doing science. Obviously, we are not training astronauts, but this kind of experiences turns out to be quite important for people that are also aiming to achieve this goal of becoming astronauts. So last year we had Dr. Proctor going to space, and just this like 2 days ago, Sarah Sabre went to space with Blue Origin, thanks to Space for Humanity Foundation. So, and Sarah was our crew member last year, and so it's like for me, it's a very fresh thing that now we have 2 analog astronauts that became space travelers. And I guess we will be start seeing that quite more often in the near future. But now I simply don't know what to make out of it, because it is obvious that we are doing something interesting here. But once again, if we look at this graph, now I have a different problem, and now I see that we are doing something interesting, that we have some potential for our science, for our analog habitat. but I still need to figure out what those great things that are happening with the people that visited us mean for our project. We are definitely very happy to be part of their journey, but I guess I will need to tell you like next year what I learned from those new uh, those new stories that I just shared with you. I guess that's it, and we can answer potential questions. Thank you very much.
Hi, and thank you for the presentation. It was really, really interesting. We don't have much time for questions, so I'll go with this one. What was the greatest challenge you had in creating a simulated habitat and the simulating the outside, inside the building?
The whole construction of or designing process was quite unique, let's say, because first we created designed those spaces like those shipping containers for a very different building, so very different structure. That was our first attempt, the Habitat Mars. Uh, and after we moved everything and we acquired this wonderful, wonderful hangar, it was really designing on the go. I was there for a month. I was calling for a crane and we were putting those modules in a different configurations, looking what will work better and what simply does not. So that was a very extreme experience because it was like analog mission with building stuff. That was quite interesting, and you were able to see how is that changing day by day. And thankfully, we had a very nice support from the local government that was all okay with that because it was those are shipping containers on a very that can be easily moved. So we had like this nice safety parachute when it comes to working in that on the go manner. That's one thing. So that was very super interesting. But then we did not only like build it, but also we are running the habitat. So it we really had to learn mission by mission how to organize a successful analog, successful simulation, and we are still learning. So we really do think that with each passing mission, both the infrastructure, the habitat is getting better, but also our procedures and our approach how to run both the scientific part, but also simulation part, because there are like those two aspects. On one hand, the researchers would like to gather good quality data and do their research, and on the other hand, we have analog astronauts that are coming here that want to learn, experience, um, and also be part of those studies. So it's a steep learning process, but you can only probably um, yeah be better and better by doing so
It's an
gradually.
evolving process.
Obviously, yeah.
All right. Well, thank you very much, and we'll pass to our next speaker now.
Thank you
So
very
have a
much.
good day, and thanks for presenting today.
Hmm.
And we'll see you on the internet and in the world of science and research.
Definitely. See you. Thank you very
All
much.
right.
Bye.
Good day. So our next speaker is PJ Marcellino. I think that's how we say it. And he's an analog astronaut who was part of the Crew 238 of the Mars Desert Research Station initiative. He's situated in the Utah desert. MDRS is one of about a dozen public and private Mars analog stations in operation and is currently the largest and longest running Mars surface simulation facility on Earth. So, welcome, PJ. I'll give you the hand. Will you have slides to present, or it's going to be all right? Cool.
No, hi, how are you?
Hi, good. So I'll
Well,
leave it to you to present, and I can't wait to hear what you have to say.
thank you very much. Well, I don't have any slides to present. I don't even have a fancy background other than that guy over there. So that's our space connection right there. Well, first of all, thank you for the invitation to the Stardust Alliance and to Jason in particular. I'm really glad that I can join you in the first Stardust Festival. I wish I could have been there in person, but it's a pleasure always, every time I'm asked to speak to young people about, in this case, about how to come into science as yourself. But in general, when I speak to young people, my focus is always on establishing that each of us has their own path, right? There is no right or wrong path to go about your life. And I think it's important to remind everyone of that because there's a lot of social pressure, a lot of pressure around in the world to comply with specific expectations. And the reality is that as you grow older, you realize that none of those matter. What matters is how you understand your life to be, how you want it to be, what you want to do, and how that fits into the overall scheme of things in your own life. So to me, it's a very special moment to be asked to do this because my path in science was not a straightforward path. In fact, my path in life has been anything but straightforward. So as I embarked in MDRS at the Mars Research Desert Station about 7 months ago now, after 2 years of standby because of the COVID pandemic, I should say that I got in as a storyteller. That's as luck would have it, they were looking to a crew that also had storytellers. And this is perhaps why I think my starting point for this particular talk is going to be storytelling. Storytelling or narrative, human narrative, is the beginning of all things, right? That's what we do as humans. We tell stories around the fire. We tell stories around the table. We tell stories when we walk, when we sit on the bus. And so I want everyone to remember that because each of us carries a story. Each of us is our own story. And there will be one day when each of us will also be sitting around the fire telling our own story. If you then extrapolate that into a bigger scale, what we are doing now here collectively, engaging in STEM awareness, but also engaging in space exploration, in Mars exploration, what we are doing is collectively telling a story that one day will be told, or we're collectively building a story that one day will be told by many people that will follow us. And so I think these are important factors to remember when perhaps when we feel less than. Leszek was actually just mentioning these barriers that we have inside our heads that tell us that we are perhaps not enough to do something. Well, those barriers are mostly in our minds, and we need to be fighting them. So my story is this. When I was a kid, my dream was to be a pilot, an airline pilot. That was always my dream. And I never dreamt of being an astronaut, and I'll tell you why. Because I was born in Europe in 1978, and in 1978, and in the decades that followed, at least until the turn of the century, there were only two flavors of astronauts. They were either American or Soviet, and I was neither. And so even for a child of my age, even though I was fascinated by astronauts and by space, it was just beyond the realm of imagination that that was reachable. I was born in Portugal. Portugal is a small country, didn't have a space program. Well, lo and behold, now there's 13 astronaut candidates at ESA, and there's a much bigger number of analog astronauts. So things have evolved. But at the time, this was completely out of reach and not something that looked logical for me to even aspire to. So I stuck to the pilot idea. Then, of course, you get older. And even as you get older, and as many of the young people and that are listening to us will understand, you start to get disillusioned with the barriers that you find in your life. And I immediately found a key barrier to being a pilot at the time. First of all, now I wear glasses because I'm becoming an old man and I start to need glasses again. But a few years ago, I kind of developed a pretty good eyesight. But at the time, I really didn't have 20/20 eyesight. And back in the period that I'm talking about, you sort of needed that to be a pilot. You also, in the place where I lived, you needed to, or that was the best path, was going through the Air Force, which was absolutely not my cup of tea. And the third element, and perhaps the most significant, was that you really needed to know a lot of math. And I'm not dumb, I understand math, but I was never a math genius. And so for all those three reasons, I very gradually gave up that idea and kind of moved on with the things that my dad and my mom would suggest, go to this particular field or that particular field. They just wanted me to succeed. Anyway, fast forward, I get to high school and I studied humanities, so law, social development, economics, but in a school that specialized in arts, so an art school. So basically, I was the only class that was of students that were not art students. So I was surrounded by these folks, and at the end of my time in high school, I had already been involved in journalist clubs in the school newspaper, which was a quite successful one and published nationally and so on, as well as environmental clubs and science clubs and language clubs. And at the very end of this, there was an European program at the time that was part of a Europe-wide effort to to build Europe, to build the idea of Europe in young people. So to build the idea that as a continent, we could be one thing. And so they were incentivizing really interchange programs that dealt with science, with language, with technology, with knowledge. And I ended up being selected for a mission, which was called Mission Antarctica, even though it was in the Arctic. So it was in the archipelago of Svalbard, up very close to the North Pole. And what this was a boat called the Antarctica at the time, now called the Tara, a polar research vessel, which was investigating global oceanic circulation and climate change already. This is like right after the Rio conference, so it's when we are starting to really talk about climate change. And so me, a Danish youth and a French youth were sent all the way to the North Pole pretty much, and lived in this boat for about a month. We first worked out of the University of Longyearbyen, which is the main city in Svalbard, and then traveled 5 hours by skidoo and ended up living in this boat with Jean-Louis Etienne, who was the owner of the boat and a famous polar researcher, and with his entire crew of scientists. Now, you have to imagine what this means for a 16-year-old. You are literally 500 kilometers from the North Pole, living on a boat that is floating on the ocean. The ocean is frozen. We're sitting on it. The boat is designed to pop out of the sea when the ice shelf comes. And there we are. And one night there's a polar bear, and the next night there's a glacier collapse. These things are happening right around us. Young people are impressionable. I was impressionable, and I usually refer to that one event in my life as my key foundational moment. Everything that happened in my life after that happened because of that one period of living and sharing my life with scientists who were kind enough to hold my hand and explain what they were doing and take me on their zodiacs while they're taking samples of icebergs and pointing out, oh, there's a seal over there. These are all fantastical things. And at the time, I felt so lucky and that I could never top that. And quite frankly, I have never topped that, even though I've done a lot of incredible things since then. But I continue to look at that as the key moment of inspiration. And I think that's what's crucial for all of us to keep our minds on here. What are the key moments of inspiration and the key moments that generate aspiration? So one of the important things in this event is that because of how it was constructed, it was aligning several things. It was aligning international connections and networks. It was aligning the knowledge of foreign languages. It was aligning journalistic skills. It was aligning STEM and technological and scientific knowledge. And the obligation of communicating all that we've learned by the time we got back. And so I spent the next few years basically doing that on behalf of the foundation and on behalf of the program. I'm still a member of this foundation to this day. I participate on their activities pretty much every year, mentorships and juries and board discussions. So I continue to be engaged with this scientific network up until this day. And in fact, during MDRS, because of the COVID pandemic, we ended up having a couple of people dropping out of the crew right ahead of the actual mission. And this is the network that I reached out to find people that could be interviewed to join the crew. So this continues to be an important part of my story. Anyway, fast forward again. I get to the end of high school, and of course, this was a cool experience for a teenager. But high school ends, and it's time to make choices again to go to university. And my parents wanted me to be a lawyer. I actually came this close to putting a cross in that little box that said law. And at the very last minute, I actually moved the pen. This is true story. I had the pen on law, and I decided to change it last minute. So I decided to pick international relations, and that's what I initially studied. I continued to be a journalist on the side, so it was kind of my side hustle while I did that, was that I was writing about environmental journalism. I was also volunteering with a couple of environmental awareness NGOs. And so my field started to be a little bit already determined by the experience that I had in the Arctic, started to be kind of conflating towards the environment. But a couple of the titles that I worked for were also working on construction, social space, urban planning, and somehow, and don't even ask me how, I started to be the guy that you would come to write critic reviews about new urban planning projects. And so by aligning my personal taste for architecture and social development and a certain knowledge about environment and the fact that I was a good journalist, all of a sudden I find myself writing more and more and more and eventually heading certain titles. And so by the time I finished college, I was well published. And so that seemed like the normal thing to do. I continued to write, and I ended up specializing in writing about environmental architecture, environmental engineering, and the political use of space in urban planning. And I wrote for media around the world in half a dozen countries. And then about 15 years ago, I decided to go back to school. I took international politics, a Bachelor of Economic Science. And then I did my master's in international development. And then that's where things shake up a little bit. Because at the time, I had already transitioned from journalism to academia. So I was kind of traveling the conference circle. I was doing really interesting research on migration and other political topics. And I was doing the circuit. But there was something that wasn't quite fitting in, right? It didn't feel like my story. And I ended up at some point transitioning. There was an opportunity, and I transitioned from academia to political advisory posts. And so I ended up working with international organizations as a political advisor and a communications advisor. And I'm talking about the United Nations. I'm talking about the African Union, the European Union, International Organization for Migrations. I'm talking about the A-list organizations. So that was my job. And it was stressful, and it was sometimes very dissatisfying, because you are putting everything that you have and that you believe in on those talks, but it's actually not going anywhere. You see that it's not going anywhere. It's not helping. And I remember feeling in one particular conference at the UN in Geneva, there has to be a better way. And perhaps as a storyteller, which I had been my entire life, as a young writer, as a photographer, I started to think that perhaps I can communicate to a wider audience if I do this in another way. And so this is how I came to briefly give up what I was doing and to go to film school, which had been a dream of mine when I was finishing high school as well. I really enjoyed film, and I wanted to go to film school. But of course, your parents are never going to advise you to do that. And I'm not blaming my parents, to be clear, but my parents wanted me to be something more feasible. But in 2012, I decided to go to documentary school, and that was a revelation. It just reminded me of all the things that I really like to do. But of course, when I finished that, I didn't really know what to do. I'm an adult. There's things going on in life. And when I finished, I was inspired, but I had no idea how to then go and become a filmmaker. And so I did what most adults would do, just find a job and go back to the things that you know how to do. So I ended up living in Ethiopia as the head of communications for the Peace and Security Department of the African Union. And again, this is where perhaps storytelling and the universe conflate, because for the sake of my story, the universe wanted that on my first meeting at my new job, my boss announces that she wants to make a movie about 50 years of peacemaking efforts in Africa. And not a single person around the table of the communications team raised their hand to lead the project. I was freshly out of film school, and so I raised my hand, and I ended up doing my first film as a producer with this organization's money, with one of the best production teams in Ethiopia, which is a country with 100 million people. So this is a serious team. And that was kind of the key turning point for me. By the time my contract in Ethiopia ended and I came back to Canada, where I currently live, I think my perspective had changed, and I have spent the last decade basically working on films that have to do with social rights, with political rights, with civil rights, with indigenous rights, with diversity. So basically all the things that I was doing prior in other ways, I have now transposed to my filmmaking career, and it has become a little bit of my brand. That is what I do. And I started with documentary, but I'm now transitioning to other narrative modes. So fast forward again, when we get to, I think 2018, well, anyway, whenever my 40th birthday was, I had a moment in which, perhaps like many 40-year-old people, in which I assessed my life. What is it that I've done, what I haven't done, what I would like to do? And I started to remember the things that I perhaps promised myself that I wanted to do and never did. So first of all, I'm still not thinking about space and astronautics at all. But I was reminded that I wanted to be a pilot. And so I enlisted in pilot school, started ground school, did a couple of flights. Then the COVID pandemic hit. But in the interim, by simply searching pilot schools Toronto, I start to get all these Google results. And lo and behold, it surfaces in front of me an ad to apply to an analog at MDRS. And I did, never thinking even remotely that they would pick me, because of course the same thing, the same insecurity from those years when I thought that astronauts were American and Soviet applies now. And my thinking now was, well, they're never going to pick a journalist, a storyteller, a political scientist. This is not what astronauts are. Turns out they were crewing a crew that was half scientific and half storytellers, because they wanted to start engaging with the storytelling element or requirement of public engagement. And this is how I end up after COVID or in the middle of COVID, how I end up in the Utah desert as the crew journalist and documentarian, and then as also the executive officer of the mission. And so all the logistical skills that I had accumulated over these years working in politics and working as a producer aligned themselves with my knowledge of media and storytelling in general on various media. And then aligned themselves as well with the fact that I had been traveling and meeting people for my entire life for work. And suddenly, it's almost like this thing came out of a box. This is also the time when I met some of the people at this conference. And by the time I came back, it seemed like something had changed. And I would love to tell you that I know where this is going, but I don't. What I do know is that the story is actually not finished, right? So am I ever going to be an astronaut? I don't think so. Am I perhaps going to be involved in the next few years as an advocate for diversity and for accessibility and for the democratic access to space and for the proper use of space, right? Because there's a lot of policy issues that are arising with this new accessibility that we have to space that are very important to address. And that's one of the things that I've done my entire life, was considering the political implications of things that are not necessarily political, but have very serious political roots. And so I'm trying to figure out what my space is in here. It's interesting that it all goes to that little bit of STEM, right? So this mission that I did in the Arctic that started me on engineering, environment, and all of that, that continues to weave through to everything that I do today on the journalistic side, so the storytelling side, on the international networking side, and in the scientific side. And so this is how I find myself here. Just a couple of days ago, CNN Portugal ran a story about the current Portuguese candidate astronauts and analog astronauts. And it just blew my mind to even be involved in this story as someone who is part of the space journey that is going on right now. So I think I'll leave it at that. I just want to reiterate the first message that I put forward, and that is that each of us is a story. Each of us will one day be sharing our story with our kids, our grandkids, around the same fires that we've been doing or telling stories around for thousands and thousands of years. And I think it is important to remember that no one but yourself determines your story. You need to give it time, take the opportunities that come your way, and don't put barriers in front of yourself that are not there. You are capable, you are absolutely able to get to where you need to be. And sometimes if you are not at the destination that you predicted, that's totally okay. Adapt, adjust, and keep going. Thank you.
Hi. So thank you for the presentation. Really interesting life story. And I like the way you bring it, where you say storytelling is important. I come from a Métis family where sharing and storytelling is a big part of what we do. And my mom's a musician also, so it's all about sharing and bringing what she lived to other places, and also the message that you bring in your life story, where not being afraid to take opportunities that show up. Lots of things appear, like the Stardust Festival for some. It's a amazing networking event where people get to see and meet and hear people's stories, and see that it's possible if you're a journalist, or if maybe you're not in the domain and maybe you dream of it, but it's still possible if you keep your sights open.
I'll tell you a little comment in regards to that, because you had my MDRS engineer Simon speaking at the Stardust Festival a couple of days ago, and we just met in Toronto yesterday, and we were talking about the fact that both our lives have changed after the mission. And one of the things I was saying was that before the summer, I went to a Mars conference in Washington with Jason and the Stardust group. Mm-hmm. And I find myself in a room full of rocket scientists and astronauts and former astronauts. And I had this moment in which I've done a lot of really incredible things in my life, make no mistake. But I had a moment in which I thought to myself and then texted my sister, I have no idea what's happening in my life, but this is bizarre, right? Um, so, I don't know where it's going, but I think it's one of those things, as I've done before in my life, you just wait and see, and you kind of assess things as you go and try to fit in with what you have to give, because at the end of the day, we all have something to give. It's about figuring out where that fits.
Hmm. Yeah, definitely. That's I mean, just myself, sometimes looking back, I see, oh, there's all kinds of situations that, just looking, like you said early on, when I think it was like a society and science sharing events. Well, those are available in different countries and in different places. I mean, I'm from Quebec, and we have a French association with France, where we have speakers from the biggest industries coming to speak about
Yeah.
science and society, and the union of both and the importance of both, which is
Yeah.
really important. And you get to meet people and see things, and they're closer
And
than you think.
really, these groups are available in most high schools, most universities, and so
Exactly.
this is where people start, right? You
Exactly.
create networks, and I can tell you, as someone I mostly work as a producer, and as a
Hmm.
producer, one of the main things that we do is network. And so let me give you my network data. When I go to a festival, if I talk to 100 people in a day, I know that one person will lead somewhere. That's a terrible ratio, because it's a lot of mental effort for that, but that one person is usually something really special. And so even though it's a lot of effort, you put in the effort, because you know that if you hit that one person, that's it, that's what that day was for.
Hmm.
And so I think it's important to keep putting ourselves through things, and putting ourselves out there, really, and allowing, working hard, but also allowing life to give you the opportunities that are there. But you do need to, well, I'll tell you what the slogan of my production company is planned serendipity. So I love
Hmm.
serendipity, but if you plan it, it's much better.
Yeah, definitely. All right. Well, thank you very much. We'll have it's pretty much the end for now. We're going to take a 15-minute break, and we'll be coming
Hmm.
back with two younger speakers later who have a lot to
Awesome.
share too. So thank you very much for your presentation and your life story, and I hope you well.
Thank you so much. Take care.
Thank you.
Yeah. I love my wall. Them home as well, right. We're very happy to have two young students here, because, having elderly people and elderly starts at how they got where they are is interesting, but hearing how young to tell the others that they can do it as well is a very happy to have Brian and Sean here. Brian is the one just had his birthday this week, right? And so tell you what they've been doing over the last years, where their heart is. For Sean, that's astronomy, sky. For Brian, it's also space, but he wants to be interested in all the mechanics and the engineering. He thinks it's all very. He wants to make sure that if we go to space, we don't harass people to each other. He wants to regulate it, which is a split regulating. Now, young man, I'm giving you the floor.
Thank you very much for the introduction.
Yeah. Thank you.
Can everyone hear us well? All right, I'm not. All right, I think so. Okay, so hello everyone. I'm gonna hold on. Let me share my screen. Let us share a screen. This one. Can everybody see the first slide of the presentation? All right, so hello, our presentation. Here, Sean, you can begin.
Here. So, welcome everyone. Our presentation is called Project-Based Learning by Brian Bartello and Sean Bartello for the Stardust Festival. So welcome everyone. We are excited to present at the Stardust Festival. We hope to share a little bit about our educational experience, as we both hope to be in aerospace. Our teacher and mentor, Artemis Westingberg, asked us to speak a little bit about some of the projects we have been involved in during the past year. So, hello, let me introduce myself. I am Sean Bartello. I want to be an aerospace engineer. I want to build rockets for NASA or one of the many commercial space company, or ULA, or Boeing, or SpaceX, or Blue Origin, or Virgin Galactic, or anyone really. I'm 10 and I will be ready to work in 10 years. My favorite subjects are engineering, science, robotics, and coding Arduinos. I like to read and play video games, also to swim and hang out with friends. I play Kerbal and Minecraft, which are both building games. Kerbal allows me to imagine that I own my own space company and that I can build rockets and send astronauts on missions to different planets and do science.
There you go. And I'm Brian Bartello, and I'm 12 years old, and as Grandma Artemis mentioned, I want to be a space lawyer. I want to settle disputes between companies and countries in regard to things like asteroid mining, territorial disputes and claims, spacecraft collisions, satellite malfunctioning, and other problems that may soon arise in the future. And I want to be part of the peaceful solution and not contribute to just more escalation of an already large problem. And I was introduced to space law by our mentor Sean Case, and I knew instantly as he described the Space Court Foundation that this would be a perfect fit for my mindset. And I haven't stopped thinking about it since he first mentioned Space Court Foundation 2 summers ago. And with my brother, we are homeschooled, and I am in the ACE program for homeschoolers in the state of New York. so I can get a head start on what interests me in aerospace, and I can earn my college credits faster. So that way, when I'm about 20, 21, I'm spending less time in college and more time working for your aerospace company. And my favorite subjects are science, debate, history, logic, math, pretty much everything. And I love video games with my friends, like Rome Total War, a strategy game, and Kerbal, Sean already described it. Minecraft, like a survival or creative game, and Roblox, basically a platform for lots of games. And here's just a couple of memes for homeschooling that I just thought were kind of funny. So yeah, I. But unlike this meme, we love homeschooling because we do it in a project-based learning. Benjamin Franklin once had a quote: "Tell me and I forget, teach me and I may remember." And that was one of the bases for uh, for project-based learning.
So, what is project-based learning? It is learning through doing. We use textbooks and workbooks to reinforce what we read. Also, we read a lot. We go to homeschooling co-ops to hang out with friends and do gym classes and electives. We also have field trip Fridays to museums, galleries, and historical sites with our class on subjects to learn more about them that we really like. We're part of a lot of study and fun groups and math circles with other students. We are even part of online Shakespeare plays our homeschooling friends put on together. So we also actively build and create things, the two of us. We learn by trial and error. For instance, I taught myself CAD or computer-aided design through trial and error and watching YouTube videos on it.
And our North Stars. First of all, we have Janet's Planet with Janet Ivy and Artemis Westenberg and Sean Case. And we started meeting with the Astro Academy during COVID, and it made us very happy, and it gave us something to do during the pandemic when we would have been scared and had nobody really to be with. But this was amazing, and it really helped hatch our love of space. Like it was kind of hidden in us, but it really shined some light on it. And we attended the recent Explore Mars Humans to Mars conference, and we met so many people that are just helping to make humanity multiplanetary and are helping push the boundaries and teach us more and more and to make us all a better species. And we actually got to meet all of our Astro Academy friends in person, which was amazing. And someday we figure we'll be working together on something big. And already we work on projects now. Like, for example, Janet and Artemis hosted Blair Cotton Hess one day, and he told us about his FAA STEM Minecraft contest, which is you have to reimagine an airport in Minecraft. And we did that with our friend Abby Rowe, and we won first place for our new version of the Chuck Yeager Airport in West Virginia. We built it to scale on Minecraft.
Well, we also had a seed experiment. With SpaceWorks high altitude balloon experiment with seeds with Enterprise in space. This was our first opportunity to be space scientists. Thanks to Janet and Artemis, and especially Sean Case, who made everything happen. We are working with Morgan Irons at Cornell University to publish our findings. We are observing the department and independent variables in order to access of if radiation has impacted the seed's growth. And spoiler alert, so far we don't see much of a difference, but we actually did see a little bit, which is just they were a little bit bigger, but that's about it. But yeah. We also learned to be relentless. Future engineers
Or is that just on our
Okay,
ends?
never mind. There you go. I'll just go back. Future engineers' challenges are some things we look forward to.
And so we learn that sometimes we win and somebody else wins. Sometimes we don't win every challenge we go into. Like, for example, the Tech Rise challenge. We worked really hard on it, but our team of 10 students from our Astro Academy did not get selected. And as the principal investigator, I managed the project proposal and wrote it up. But I'm wondering if I could have written it differently, maybe we would have got it.
Well, if any of you heard it, I went to the invention convention. So if you haven't heard of it, what it is, each year people participate in the local invention convention. It is a science fair for the future. We both have won various awards in it. Brian won the Sustainability Award for the Recyclinator and an app design for each day. And he made it each day because it sounds kind of like beach day, and it's an app to clean up beaches. So, and I got to go to the national competitive. I got to go to the National Invention Convention 2 times in Detroit. I made a Seeing Stars Observatory. So you make a constellation. I made constellations with LEDs and copper tape, and then if you click a button, if you get the constellation right on a piece on the paper, it will light up. But if you don't get it right, it doesn't. And this year I made Architects, which is a cell phone holder I made from architecture. And I got the name Architects from when I misspoke architect from last speaking my brother. And
some STEM groups we participate in here's a couple. So first, one of the big ones is we're going to go to Astronova School online in synthesis to learn problem solving and communication skills, and Josh Down's vision for how to think critically, work in a team, and build consensus with kindness. And quote, Astronova is an experimental online school for kind, independent, and daring kids. Born at SpaceX and by Small Design, available to students ages 10 to 14 around the world. This is Josh Don's vision, and I just adore it. And we cannot wait to start very soon. And some other ones we participate in is we also participate in the Aerospace Innovation Academy, which has policy training, how to research and write, and eventually we're going to help to build small blue cube satellites with a team. And I want to just thank Owen Welch for telling us about Mr. Kevin Simmons and Miss Shauna Christensen. And we learned that it's all about spreading the word about cool things.
And some more STEAM groups we participate in. What we do there is we have quite a lot of different camps that of 3 hours, and we went to I think every one so far this summer. So the first one is an Arduino one, coding Arduinos and building Arduinos to make it do different things. And we went to a mission control center created by the families of the crew of the Space and Shuttle Center, the Shuttle Challenger, and such as each Arduino coding camp and astronomy camp. And the one we're doing right now is first Lego Robotics team with our friends through Challenge and Learning Center. So what it is we build Lego Robotics, and then we have to do 15 different challenges with a robot.
And I am in the ECI Environmental Fellowship. And I'm actually I landed a position as a new content editor for the student group, where we seek to affect change through education, science, and business, supporting sustainable options. and we want to help the economy while also wanting change, but we're not pushing it like a protest. We do it in a more scientific fashion, and we actually work with business to get this done. And I hope to highlight space debris issues in the future, because that way, once we can trust ourselves to take good care of Earth, we can also trust ourselves to take care of Mars and other celestial bodies. And another STEM group we participate in is I'm in the Mars mission student group, summer camp missions, and we get to learn about spacesuits with Dr. Larry Kuznets from Planetary Protection Group, I want from Space Kids Global. I won a zero G flight from Sharon Hagel and Space Kids Global at Kennedy Space Center. I won an essay contest about why I want to experience zero gravity. Mainly, I want to experience about the people I'll be working with and will be experiencing. I like to understand by doing. And we learn with our friends in online groups and classes. Homeschool co-ops are great, but most of our friends are not into space, so we find our friends online and talk on Discord and meet on Zoom to chat and play video games like Dungeons and Dragons. And we also have science and math Olympiads with our math circle called Many Math Circles and more with our friends. And we do art and drawing classes too. And we do math through ThinkWell. In fact, the head professor for the math, Dr. Edward Berger, we're going to be able to meet him in about a week. So we are very excited about that. And we do book battle teams. And we all read the same questions and see which team gets to read the most closely. Winners get to flex.
So, any questions?
Check the comments.
Hi, I do have news from all the places where you could learn.
Huh?
Would you go to different countries too? Or would you prefer to do the big?
Yeah. Maybe. Sorry, you broke up. Could you repeat the question?
Question was, if you would go after this, you go to do university in other countries or states where you live.
Maybe.
Well, we are planning to go to the University of Buffalo, which is right here in New York, which only like 20 minutes away from us, and it's a great university.
You look at your future, and I know that you're doing it the way you do is about you, right? That's the big difference, of course. So you education. And you were talking about 1 or 20. Pick what in New York?
Well,
it's still wide
so
open.
far we're wondering about like which aerospace company. I'm thinking about NASA Relativity Space, but I'm not sure yet.
He's way open. And my field isn't super large yet, but I know it will be in the future. I'll have more of an idea when this field really starts burgeoning.
Because I know in Europe there is a smarter. So there are else you want to add before we ring off?
Hi. So, I just wanted to thank you guys for your kids your age know what's available out there and the accessibility of learning to have you guys here. So, I've dreamed of having these kinds of there until I started university and the events and I just find it amazing that these, and I think it's really awesome what you guys are doing. It is awesome. That's amazing too.
Thank you.
And we have a few people in chat who are also really, and I have my mom also on. Awesome homeschool and in your path and everything. So
Well,
Thank you.
I example of where you want to learn it. And online, there are so many people that are willing to help assist kids in learning stuff. To go online, and that goes for all our audience, whether your specific interest doesn't have, an online kids group, or perhaps even something near where you research. And if you find it, where the path leads you, that would be my advice.
online, there are a lot of groups talking about science and technology and platforms, and they exist. They're there.
Communities. The only thing that is lacking your ambition to be part of it. You that got a little ambition or a lot of ambition, interesting contact, and an interesting voice. Thank you. Well, we'll talk again, I hope.
Thank you very much.
Well, thank you.
It's a pleasure to present.
Having you here.
Thank you.
Good day. All right, so we'll be back this afternoon, and I hope to see you all here, and we'll see you later.